Hi everyone, I am just recording the next in this video series, trying to do question number 4, review exercise 3.4. Just going to make a new page. You can see I'm doing these one right after another here. So this is 3.4, review exercise. And so question 1 is needed to do question 3. In this situation, question 2 is going to be used to solve the problems in question 4. So number 4 says, determine the value of the normal variable x naught for the probabilities below. Okay, and we're going to use, what are we going to use here? And we always, for any of these questions when we're dealing with x, we always need some mu. Pardon me. Always need some mean, mu, and we always need some standard deviation, sigma. So this is 0.4. So now question A. So this is the probability that 1.8 is less than x naught. Now, the first thing you should do here is just straight away convert everything to x, and you don't need to do anything fancy. Well, kind of fancy. So the first thing you should do, so you have x, or no, sorry, this is z naught. That's the one you're ultimately looking for so that you can convert back to x naught at the end. But you still actually have a z1 as well because you're given a value. So figure that value out first using the methods that we used originally. Actually, you know what? I'm going to make up a question. I don't like this as our starting question. Let's just start with something really easy. Let's say that we have the probability that oh, never mind. That one is easy. Okay, let's do it this way. So A, we have the probability that 1.8 is less than x naught. Well, actually, here's a neat thing. This is equal to our mean mu. So we actually know that because when I draw the graph, on the standard normal distribution, this is 0. Right? And for a regular normally distributed random variable that isn't a standard normal random variable, this mean is the mean that's given here. So this is equal to the probability that 0 is less than z, again, because 1.8 in a normally distributed random variable is like this. So this should be 1.8 if I'm working with x. But when I convert it, it's going to be 0. So 1.8 is 0. And then, actually, easily enough, we can just put z naught right here. We don't actually have to do much conversion for this first step unless this number happens to not be the mean. Okay? And we'll talk about that. But for now, we don't have to do anything. In fact, right now, we're going to be doing exactly what we did in question 2. Except at the very end of the problem, we're going to have to convert from z naught back to x naught. Okay, so let's do it. We know that we're trying to find, this is z naught. And we're finding that region up to here. And actually, this problem, we were given that this was equal to 0.3212. This was given to us in the problem. I know that this wasn't, but this was equal to this. So naturally, if this is equal to this, or this probability is equal to this probability, then it should also be equal to this. Well, then it's one of those more easy problems from like question 2. We just need to look that probability up. Where's 3212? I already have it underlined. 0.92. So this is equal to the probability, or actually what this is saying is that z naught is equal to 0.92. Okay, I'm not done yet. I have to use the reverse z score to give me my answer. So z naught is equal to x naught minus mu over sigma. Well, I know, now that I know this z naught, I have this variable, and this variable. So basically, because of course I have the mean, I have the standard deviation, and I have the other z naught. So all I need to do now is take these numbers and do a little bit of algebra, and I'm going to be able to find that x naught that I'm looking for. So z naught is 0.92 equals x naught minus 1.8 over 0.4. Now we do a little bit of algebra. So times by 0.4 times by 0.4. Can't do decimal multiplication in my head, so I'm going to have to use my calculator. Times 0.92 this is going to be equal to 0.368 is equal to x naught minus 1.8, and then I just add in 1.8. Add in 1.8. So add 1.8, and I get x naught equals 2.168. Okay, so then what this means is that the probability, or well, you know what? We're done. I know I'm scratching a lot of stuff out here, but we're done. All right, next step, we'll do B. We have the probability that negative x naught is less than x is less than x naught is equal to 0.9942. Okay, well, this is actually not too bad, because what this is saying is that the probability that negative z naught, because there's no other numbers in here, there's just variables, I can just replace these and say, look, it's equal to this number. Of course, at the very end, I'm going to still have to do this conversion step where I convert the z naught that I get to an x naught, but at least the first step, I can just do that. Okay, so now what this is saying, this is actually a lot like, if you remember question 2b, it's a lot like that. Actually, it's almost identical to that. Actually, you know what? We're going to save ourselves a bit of time here. We already know what this z naught is. We figured it out in question 2b, right? Because look, what did 2b say? It said negative z naught to z is 0.9942. So what we can just do is, we already know it. We know that z naught, well, I'll draw this anyway, but it's not going to matter. Z naught, as it says right here, right? This is the exact same question, is 2.76. Okay, and now I just have to do that same process that I did up here. So z naught is equal to x naught minus mu over sigma. So we have 2.76 is equal to x naught minus mu, which is 1.8, divided by sigma, which is 0.4. And let's figure this out right here. I'm going to skip some steps here. Well, no, let's not skip the steps. Let's do the steps while we're times 0.4. So this is 0.4 times 2.76. So then we have 1.104 equals x naught minus 1.8. So I'm just going to add that. I can just use my algebra to add 1.8. Add 1.8. And I get x naught equals 2.904. Not bad. Okay, we'll call this page 8. Keep working through these. And actually, we sort of set these problems up so that a little bit of time could be saved by looking at the questions that are related to them in question 2. So number 4C, we have the probability that 1.00 is less than x naught. This is equal to 0.0757 by the looks of things. Unfortunately, in this situation, we don't have one that we can directly rely on from question 2, but that's no problem. We'll work through it. So we do have to do a little bit of work here to get to this situation. This is what we want to get to, and we need to fill that number in. Oh my gosh, why did I made that these should be z's, okay? These should be z's, these should be x's, and there should be a conversion that gets us from this 1 down to here. Now remember, mu was equal to 1.8, and sigma was equal to 0.4. So we have to use this z equals x minus mu over sigma to get us here. And actually we have to use it in the way that we did it in question 3. We have to go this value right here, we'll call this z1. z1 equals x1, which is we're going to say is 1. So 1.00 minus mu, which is 1.8, over sigma, which is 0.4. What I get is 1 minus 1.8 divided by 0.4 is going to give me negative 2. Okay? So this is saying that the probability that negative 2 or 7 is between negative 2 and some other number is equal to 0.0757. Right? And it's going to give me this x value once I get to the end. So let's draw it out, because now we're back in the world of z's. And this is 0 and this is negative 2. That's the one number we know. And we know that z is going to have to be larger, so I'm going to have to start shading this way. But this is a relatively small number. So it's very unlikely that I'm going to have to shade past this line right here. Remember, everything changes when you have to shade up and past a 0 line, because then you have to break things up a little bit further to make sure that it works with our standard normal table over here. But I don't think we have to go there. We don't have to go there. We just have z0 over here. But we still have to make use of a little bit of algebra. So remember, whenever we have a situation like this where we have a region and then nothing between 0 and the next number, we have to consider the whole region and subtract away the region that we are not interested in. So if we remember correctly, p negative 2 less than z less than z0 is equal to the probability that negative 2, that z is between negative 2 and 0, minus the probability that z0, or that z is between z0 and 0. Now this is going to help us, and we know the value of this number. This is going to be 0.0757. And we know we can actually look the value of this number up on our table. So negative 2.4772 minus this number over here. Okay, do a little bit of algebra. So the best way to do this is I'm going to add probability of z0. Well, no, actually what I'm going to do is I'm going to subtract off 0.4772 minus 0.4772, and I get 0.0757 minus 0.4772, and I get negative 0.4015, and that's equal to negative probability that z0 is less than z is less than 0. Now, the reason I paused was because I realized I have a negative number in front of my probability. Now, you should never have a negative number in front of your probability. Your probability should always be positive, but this is kind of an intermediate step. Because there's a negative on this side and a negative on this side, you can actually divide by negative 1, divide by negative 1, and it lets you cancel these negatives with the negative 1, negative with the negative 1, and we get that the probability that z0 is less than z is less than 0 is just equal to 0.4772, which we can look up on the chart. Or no, not, looked at the wrong number. 0.4015. So we're going to look at the chart. 0.4015, where are we? 4015 is right here. So 0.4015, this is 1.29. So this is z0 is equal to 1.29. And we're not done yet. We still have to figure out that x0. These take a while. So we still have to find that x0. And we're still going to use this value right here. So we have z0 equals x0 minus mu over sigma. Now z0 is 1.29. This is equal to x0 minus 1.8 divided by 0.4. I'm going to do this one quickly. 1.29 times 0.4, and then we're just going to add 1.8. So if we solve this, x naught equals 2.316. Okay. So again, we keep building up this toolkit that's going to eventually let us solve word problems, okay? And typically, when we get to word problems, this x naught is going to have a meaning. It's going to say be the number for which 7% of people, the number that sort of makes a region that 7% of your sample points reside in. There's going to be a lot more meaning in a little bit here. But for now, we're just doing it this way. Okay, last one, and I hope I have enough room to fit this all in. D, the probability that x naught is less than x is less than 1.8. Love this question, 0.4. So this is actually the interesting thing is if I were to, this is the probability that you have the lower 40% of people. Well, we'll leave the explanation for the next question, but I like this question because this is just equal to mu. So what this is actually saying is, and I can do this conversion really easily, the probability that z naught is less than z is less than 0 is equal to 0.4. So it makes my job really easy because all I have to do is find 4,000 on here. Now the unfortunate thing we have here is that there's no 4,000. 4,000 is, well, not 4,000, but 0.4000 is like somewhere in here. But I'm just going to go ahead and round it because this number is so close to 0.4 that we really don't need to worry about it. If you can't ever find a number in this table when you're doing this reverse engineering process, when you're trying to find this z naught, but you don't quite have this number on the table, just go to the next closest. Or if it's too far away, you can always kind of take the midpoint. So if instead this were 0.4007 or something like that, I would say just take the average of these. Well, I'd say take the highest one and the lowest one and take the average of them. But in this case, it's close enough to this number that we'll just say it's that number. So let's take a look here. 1.28. So this is saying that z naught is equal to negative 1.28. Remember, because of course this is a negative number because z naught is definitely less than 0. That's how I know this is a negative. And then we just have to do that same process that we did up here to get x naught. So this is negative 1.28. This is equal to x naught minus 1.8 over 0.4. Let's work that out. We have 1.28 negative times 0.4 plus 1.8. We get x naught equals 1.288. And that's our answer. Okay, hope you enjoyed the video, and hope you have a nice day.